Solving with variables on both sides, day 3. Alright, we have two triangles, and apparently they have the same perimeter. So we need to figure out what x is. Well, the perimeter means to add all the sides together. So for the first triangle, you have x plus 2 plus x plus 2 plus x plus 2. That has to equal the second triangle's perimeter. 2x plus 3x plus x plus 3. Well, we need to collect the like terms together. So I see x, x, and x on this side. So that makes a total of 3x. And then I see 2, 2, and 2. So that makes a total of 6. On the other side, I have 2x, 3x, and x, making a total of 6x. And then I have my 3 over here, so plus 3. Okay, to solve, I will get the x's together. So minus 3x, minus 3x. Then we're going to have 6 equals 3x plus 3. And then I'll subtract 3 on both sides. So I've got 3 equals 3x. Divide by 3 on both sides. So x has to equal 1. Then the second question is, what is the perimeter of each triangle? Well, if x is equal to 1, we should be able to figure that out. If x is 1, then this side is 2. If x is 1, this side is 4. And if x is 1, this side is 3. So the perimeter has to be 3 plus 2 plus 4, which comes out to 9. So the perimeter is 9. We could check this by using 1 in the other triangle. All 3 sides would be 3, and 3 plus 3 plus 3, of course, is 9 as well. Alright, next problem. Tina and Tammy work at the pool in the afternoons and also get a weekly allowance from their parents. The pool pays them the same amount per day, so they're going to get the same amount. Tina works 4 days a week and gets $10 per week allowance from her parents. Tammy works at the pool 3 days a week and gets an extra $60 each week for allowance. It takes Tina 4 weeks to earn the same amount of money that Tammy earns in 3 weeks. Okay, we want to write an equation for that situation. So let's let P be their pay. Since they both get the same pay, you can use P for both. So let's do Tina. Tina gets 4 days of pay and $10 from her parents that week. Tammy works 3 days during the week and she gets $60 from her parents. So it takes Tina 4 weeks to earn the same amount of money as Tammy earns in 3 weeks. Okay, well, I don't think that information is really that important. I don't think that we need to know that. What we want to know is that they're going to earn the same amount of money in Tina's going to work 4 weeks and Tammy's going to do it in 3. So we set the equations equal. So 4p plus 10 equals 3p plus 60. So we're going to subtract 3p on both sides. P plus 10 equals 60. And so you're going to subtract 10 on both sides. P is going to equal 50. So they make $50 in pay. The reason I said that it takes Tina 4 weeks to earn the same amount of money as Tammy earns in 3 weeks is not important is because if you look at your packet, the question that we gave you is actually different than this question that I have here. We just wanted to know how long would it take for the two of them to have the same amount of money. So we changed the question in your packet, so my work should match your question in your packet. Alright, Wendy has 3 packages of gum and 2 pieces of gum. Helen has 4 packages of gum and 4 pieces of gum. Peter has 2 packages of gum and 8 pieces of gum, and David has 4 packages of gum and 11 pieces of gum. The girls counted all their gum and found that they had the same number of pieces as the boys. So in this case, girls equal boys, right? the question is, how many pieces of gum are in each package? So, let's let P equal the pieces of gum in each package. Alright, so an expression for the girls' gum. Helen has 4 packages and Wendy has 3. So between the two of them they have 7 packages. But they also have 6 pieces of gum because Wendy has 2 and Helen has 4, so a total of 6 pieces of gum. Okay, now for the boys, Peter has 2 packages and David has 4, so they have 6 packages together, and Peter has 8 pieces, David has 11, making a total of 19 pieces of gum for the boys there. Use these expressions to write an equation showing that they have the same amount. So 7p plus 6 equals 6p plus 19. So now we got to get the p's together. Subtract 6p. So we get p plus 6 equals 19. So now we subtract 6 on both sides, and p is going to equal 13. So there are 13 pieces of gum in each package. Alright, last but not least, we got to solve just some problems here. Again, you distribute first, then collect like terms, then get x's on the same side, and then use inverse operations to solve. Alright, so on question number 5, I see that I need to distribute. 4 times x is 4x, 4 times 2 is 8, and that equals 3x. Now I want the x's on the same side, so I'm going to subtract 4x on both sides. So I get 8 equals negative x. Well, I don't want negative x, so I divide by negative 1 on both sides. So x will equal 8. To check your answer, it says to check your answer, you could plug 8 back into the equation, the original equation. So like 4, 8 plus 2, and then you want to check to see does that equal 3 times 8. Well, 8 times 2 is 10, and 3 times 8 is, oh, we're talking negative 8. Oh, sorry about that. X is negative 8. So I knew I had done it wrong because when I went to calculate the other side, it wasn't going to be equal. So now if I do it, 4 times negative 8 plus 2, that should equal 3 times negative 8. Well, this is 4 times negative 6. 3 times negative 8 is negative 24, and 4 times negative 6 is negative 24. Alright, so the next equation. I do need to distribute that 5. So I have 3y plus, that's going to be 5y, and then plus 15. That will equal 8y. I do need to combine some like terms. 3y and 5y is 8y. So 8y plus 15 equals 8y. I then need to get my y's on the same side. So minus 8y, minus 8y. That one cancels, so I get 15 equals, and that one cancels. Well, there has to be something over there, and when they cancel, it is 0. 15 equals 0? That's impossible, so this is a no real solution case. Alright, number 7, I'd see distribution again, so I'm going to take care of that. But on the left-hand side, I also see combine like terms. 4n minus 2n is 2n, and then you got your plus 6. On this side, you distribute. 2 times n is 2n, 2 times 3 is 6. Then I'm going to collect my x's on one side, so negative 2, n. Okay, so that makes 6 equals 6. Well, that's true all the time. So this is all real solutions. Any number I plug into that equation will work. Alright, number 8. Oh, I see lots of distributing. So I'm going to copy the 36. I'm going to do negative 2 times c, which is negative 2c. Negative 2 times negative 28 is positive 56. That equals Negative 4 times 2c is negative 8c. Negative 4 times 52 is negative 208. Okay, on this left-hand side, I need to collect my 36 and my 56. So I'm going to have negative 2c plus 92. And that equals negative 8c minus 208. Now I'm going to get my c's together. I'm going to add 8c to both sides. So over here this is 6c plus 92, and over here this is negative 208, running out of space. I'm going to subtract 92 on both sides, so that's going to be 6c equals negative 300, and then I'm going to divide by 6, and c is going to equal 50. Number 9, got to distribute, lots of distribute. Negative 3 times 2 is negative 6n. Negative 3 times negative 5 is positive 15. Half times negative 12n is negative 6n. And half times 30 is plus 15. If I add 6n to both sides, collect my variables on the same side, I get 15 equals 15. Again, that's all the time, so this is all real solutions. Alright, last but not least. Sorry I'm going so fast. Alright, on this one I'm missing, there's supposed to be a 1/5 here. Hold on just 1 second, I'll add it in for us. Okay, so 1/5. Alright, so I need my variables on the same side, so I subtract 2h on both sides. So that leaves me with 1/5 over here, and that equals 2h plus 1/5. I can subtract 1/5 on both sides. Use your calculator. 1/5 minus 1/5 is 0, and that equals 2h. Well, when 0 equals 2h, I still divide by 2. 0 divided by 2 is 0, so h is 0.